Hey all, welcome back to another math video. In today's video, we're going to be talking about how we can prove that lines are perpendicular. In the last video you saw, what do we do to prove that lines are parallel? So let's go ahead and talk about how are perpendicular lines related to each other. So here we have the formal definition of how two lines can be perpendicular in geometry. So if we know that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So if we get those lines, we find the slopes of each of those lines and we multiply them. If we get -1 as a result, we know that those lines are perpendicular. The other way we can prove that lines are perpendicular is if we have one vertical line and one horizontal line. If we know that one line is completely vertical and one line is completely horizontal, we know that pretty much like this figure, we know that these two lines would be perpendicular. Again, what is a perpendicular line? Perpendicular lines are lines that cross each other at a 90-degree angle. And we've learned that if their slopes multiply and have a product of -1, this will always be the case as well. So how can we prove that two lines are perpendicular? Well, we have to find these two lines' slope, and then we have to multiply them by each other and see if we do get -1. So let's go ahead and let's look at some lines, and we're going to choose some of these lines and we're going to see, can we prove that their slopes are perpendicular? Right off the bat though, here I can see one of the examples that I saw above, where I have one vertical line and one horizontal line, and these two lines are crossing each other. Here I can see that I have line R highlighted in yellow, and I can see it looks like line S here, highlighted in blue, is horizontal. So we have line R and line S. We know that because one of them is horizontal and the other line is vertical, these two lines right off the bat would be perpendicular. And as you can see from above, there's actually a special way to denote when two lines are perpendicular. We use sort of that upside down T. So one way that I can say that these two lines are perpendicular is to simply write line R, which they denote as R, so we can say R is perpendicular to S. Okay. Now let's actually try to see. Let's find two lines that look like they can be perpendicular, but we actually need to find their slopes to do so. So the next set of lines that I feel might be perpendicular are these two. I can see line E here, and I can see line D. So I got a feeling that these two lines might be perpendicular because the way they cross each other looks like it's forming a 90-degree angle. So in order to find their slopes when we have the graph, I always recommend using the formula of rise over run. And we did this as well when we were trying to prove that lines are parallel. So what we do is we find the slope of each line separately. So first let's try to find the slope to line D. So line D, it's rise over run. So I'm going to go ahead and unhighlight them, and what we're going to do is we're going to pick 2 points on line D. Doesn't matter which 2 points those are, it can be any point. So I'm going to go ahead and I'm going to choose this one down here, and then I'll choose this one right here where it looks like a few lines are intersecting each other. And again, I just trace out the path from one point to another by only moving vertically and horizontally. So basically, in order for this dot to get to this dot, how does it need to move? Well, it needs to go up 1, 2, 3, 4 spaces, and to the right 2 spaces. So that vertical movement is what we call our rise. It went up 4 spaces, and because it went up and not down, this is going to be a positive number. So we're going to put a +4 here. That was our rise. And how much did we run? Well, we ran 2 spaces. So here we have a 2. So we have the slope of 4 divided by 2. That is simply 2. That's what we get for line D. Now let's find the slope for line E. And again, we're just going to pick 2 points on line E. So I'm going to go ahead and select this point. Or actually, let me move down a little more. Let's choose this point, and we're going to choose its x-intercept. So we're going to choose these 2 points. And I can see here that, again, I'm going to sort of map out the distance between the points. I move down 2 spaces, and I go to the right 4 spaces. So if I'm trying to write this line's rise over run, I would have m equals rise over run. So in this case, its rise went downwards. So because it went down 2 spaces, it's a -2. And it ran, in this case, for 4 spaces. So I'm going to have a 4 here. Okay. Simplifying this, I would get a -1/2. So here's what we have to do. Here's the next step that we have to do for perpendicular lines that's different from parallel lines. For parallel lines, to prove that lines are parallel, I just have to show that they have the same exact slope. For perpendicular lines, I have to multiply these 2 slopes to each other and show that it equals -1. So if I get these 2 slopes, so the slope of line D is 2 times the slope of line E, which is -1/2. If I multiply these 2 together, I actually do get a -1, which means that line D is also perpendicular to line E. Again, this is true because their slopes have the product of -1. So because their slopes have the product of -1, we know that these 2 lines are perpendicular. If you were to try it out with any of these other lines, you'd actually find out that these are the only lines that are going to be perpendicular, so R and S, D and E. The other lines actually, unfortunately, are not perpendicular. So you can test this out on your own and you'd get different slopes and you'd find out, well, hey, these lines actually do not end up working out. You get a different number when you multiply their slopes. So hopefully now you feel comfortable with being able to prove that lines are perpendicular. Again, how do I do this? Well, you get their slopes of the 2 lines that you're questioning, you multiply those together, and you try to see if you get -1. If you get -1, those 2 lines are perpendicular. If you get anything else, you can't say nothing. Okay? So, what I'd like you to do is I'd like you to watch this next video that's going to show you how to write the equation of a line that's parallel and perpendicular to another line. So hopefully you stay tuned to that. As always, thank you for watching.